Second grade fractions, math dive in about 5. My name is Emily Divisio and my partner today is
Daryl Frost. Welcome.
As with every math dive in 5, we're going to go ahead and start you with a task. We ask that you please pause the video, complete the task on your own, or if you're planning with a grade level team or partner, go ahead and work on it together and have conversations about the different strategies that students could use to determine if the images below are partitioned into thirds. See you back in a minute. So Daryl, we're just going to talk a little bit about this because we do have our Maths to Best PowerPoint videos that you can watch to see the transition from the previous standards to our new best standards.
Correct.
Within, this is a previous grade level concept. This is from first grade where they have been working with partitioning, with halves and fourths.
Right.
And we follow the same suit within second grade. However, we're now adding thirds into compilation. It's important to point out, though, that the students do not need to write these in fractional notation.
Okay.
What is new to second grade is partitioning rectangles into equal size pieces, but the pieces may not be the same shape. So they may not be mirror images of each other as students have been exposed to in the past. They will also talk a little bit about symmetry and, as I said, mirror images of each other. And here you can see how that builds upon what they're going to learn in third grade.
So that's that whole notion of equal size parts of the same whole but different shapes. That's going to be very challenging.
Oh, stay tuned, Daryl. I think I have some great instructional strategies for you that will support students with that understanding. So Daryl, as you see here, we're going to focus a little bit about partitioning our shapes into equal size parts. And I have thirds highlighted because, again, that is new to second grade. They have worked on halves and fourths in first grade.
Okay, yes.
So here we see our first figure. And what do you see here, Daryl?
Well, if I'm thinking, what I like to do is I like to anticipate an exemplar answer for what I would want a second grader to say here. So I would want them to say that I see fourths and the parts are equal. They look identical. So they're equal size parts. They are congruent. They're mirror images of each other. So I know that what I'm looking at there are fourths.
That's right. So if I give you 2 additional rectangles to look at, what do you notice that is the same or that is different?
Well, I can make an easy connection to the third one all the way to the right because you have, if I'm thinking about horizontal and vertical partitioning, which is language I'd want a second grader to use, the third one has been partitioned into vertically into fourths. And again, I see those mirror images of each other. So I know that's another way to take that whole and partition into fourths.
So you told me the one that's on the far left and the one on the far right are partitioned into 4 equal parts.
Yes.
And the equal parts within there are mirror images of each other. So they're the same size, same shape.
Correct.
They show congruency, right?
Yes.
What do you notice about the middle rectangle that is maybe different? I see that that's divided into 4 equal sections as well.
Well, I see it's in, there's 4 different pieces. I don't see them as equal size because unlike this one compared to the other 2, I don't see mirror images of each other.
So some pieces are smaller
than others. Some pieces are smaller or larger than others. So I would disagree and say that that is not fourths. And that's really the kind of the language I would want a second grader to justify why it's not in fourths.
Okay. So the conversation that we just had is a great lead into what students will later be exposed to within the geometry unit and focused on lines of symmetry. So we talked a little bit about those mirror images, same size, same shape, but we noticed with the middle rectangle that the parts are not equal or congruent.
Exactly. Yeah.
So Daryl, I have some other figures here on the slide that I would like us to take a look at. Here we could see, just like we talked about on the previous slide, that we see 3 rectangles that are divided, the same whole, and they're divided into equal parts, which is 4 equal congruent parts. So we would call that fourths.
Yes.
But what happens when we look at this figure here?
Oh, well, I could see a second grader being on the struggle bus with that, because to this point, I'm thinking as a second grader that the pieces have to be the same size, same shape, mirror images of each other, but I'm not seeing that there. So, I initially would think a second grader might say it's not for that reason. So my wondering is, how can I help students be able to figure out that not everything, that pieces that are don't have to be the same size and same shape? How can I help them reason through that that's still fourths?
It's very important, right? So we have to be careful with the language we're using here, that we want students to be able to understand that the figures can be partitioned in multiple ways, and that the equal parts can look different, but they still represent an equal amount of the whole. So we're going to talk about that on the next slide, Daryl, and some instructional strategies or practices we could use to support our students with building understanding of that.
Gotcha.
I just think it's very important, as it says here, that we do expose our students to equal size parts that are the same size, but they have a different shape. So therefore, this is where that symmetry comes in again. These do not create a mirror image of each other, whereas
Right.
the first 3 rectangles do.
And we're falling short of the standard if we don't introduce or bring into our instruction shapes that are still fourths, thirds, or halves, but they look different.
Right. So they're still equal size parts, but they look different.
They look different. Yeah.
So Daryl, we talked a lot about fourths, and we know that thirds is new to second grade. So we
Yes.
have to look at different shapes within the same whole with using thirds as well. So here you can see we have 2 rectangles that are showing equal parts, or thirds, right? 3 equal parts.
Absolutely.
And they're also mirror images of each other. Each of the equal parts looks the same. So what happens again if I show this particular example to our students? What do we anticipate our students to do?
Well, I'm speaking as thinking about a practitioner of mathematics. I'm a second grade teacher. Just showing them that, they're not going to see that as thirds.
Mm-hmm.
So my wondering is how I think about the CRA process. Is there a tool that I could use somehow that they could build that, where they can make that connection to see that it's thirds?
Daryl, I'm glad you brought that up, because you're right. The pieces are not the same shape, but they are still equal to the pieces of the whole, right? So I do have thirds. And a great tool to show that concrete model is color tiles.
Okay.
So here you could see it's taking 6 red color tiles to fill in or cover the surface of the top rectangle.
Yep.
Therefore, I should be able to assume that then each of the other 2 rectangles within that particular shape should also take 6 color tiles. So they're different shapes, but they're the same size or area, as we say.
I see it now, because I was actually visualizing the 2 rows of 3, because if each had 6 color tiles, they're just configured differently.
Right.
But they're still thirds.
Right. I'm not changing the amount of color tiles I'm using. I'm
No.
still using 6. I'm just rearranging them differently.
Yep.
So to answer your question, color tiles is a fabulous tool to use as a concrete model or representation to build that student understanding.
Yes. Now I get it.
Daryl, in planning, we have to anticipate some of the misconceptions our students may have with fractions and partitioning into equal groups. One of the teacher practices that I found, instructional strategies to support the students with some misconceptions if they're having difficulty with partitioning, is to actually bring it to real context and relate it to the real world. I know that if I'm sharing a cake with myself and 2 friends, you better bet that I want to have a fair share of
Right,
a piece
yeah.
of that cake,
Food
right?
is good with fractions.
Yes. So we want to have those conversations with our students and
Mhm.
talking about, are these fair shares?
Exactly.
So Daryl, we've talked a lot about this particular idea and misconception students may have with understanding that the parts they're equal, but they may not look identical. And here you can see a suggested teaching implication would be to use the color tiles.
Exactly. You could also, I've done this before, I didn't think about it earlier. You could also fold paper.
Mm-hmm.
With the
So-
same idea.
So 2 different teaching implications, but to support that particular misconception if students have it.
Absolutely.
So here we see, Daryl, that I'm starting with the abstract, and we do want our students to get there. But what's important to point out is that we have to remain fluid. So we may be able to look at some things within fractions as abstract, such as dividing a particular shape into equal parts that are mirror images of each other. However, when we're working with more complex concepts, such as same size, but maybe a different shape within the whole, it's great to use those pieces that you talked about, the pieces of paper and folding, or perhaps bringing out the geo boards so that you can see that they're making smaller rectangles or squares in there and how many squares fit within each of those equal parts.
I never thought about geo boards. That makes total sense. So that's another tool we could use.
And of course the color tiles that we've talked about as
Yes.
well. But then also we want our students to transfer that to representational thinking where they could perhaps draw a picture and show the equal sized parts as well.
Sure. And then of course that leads to the abstract.
Thank you for joining us today. We look forward to seeing you in our next Math to Dive in 5, which is Unit 5. Have a great day.
Bye.